Thank you all for coming out to Patterns Meetup tonight. We're so excited to have NASA here as our special guest as we talk about wearable technology. I'm Janine Blevins. I'm one of the co-founders of Pattern. And just wanted to give you a little context before we get into the night and invite our special presenters up on stage. For those of you who've never been to a Pattern before, Pattern is a community for fashion that we started here in Indianapolis a few years ago in 2010. And the purpose of Pattern is to get people together, to network, to connect, to build businesses that are fashion related or something in that space, and to provide resources and a support system for all of those who are out there working on their fashion businesses. Now we have a lot of enthusiasts who are here tonight as well and supporters, so you don't have to be a fashion professional to enjoy Pattern. Many of you also probably know, in addition to our monthly meetups, we also put out a magazine twice a year. And that magazine is an opportunity to showcase talent in Indianapolis, and it's put together by a really awesome base of volunteers and talented professionals who donate their time and labor to put together a gorgeous magazine that's printed, and it's distributed around the world and maybe someday intergalactically if we continue our relationship with our friends here tonight. So I wanted to do a big thank you to our venue sponsor. Thank you to the Indiana State Museum. They've been so wonderful and have really made this a very easy event to throw, from providing this really beautiful auditorium to working with the IMAX to have us set up for that happy hour that we all enjoyed before this. We also want to thank Destination Station. They're the reason that we're here tonight talking with our friends from the NASA Johnson Space Center. And the exhibit for Destination Station just opened. It's here at the Indiana State Museum through June 29th. They have lots of events around the city that you can also check out. I know that they're going to be here in the White River State Park for Earth Day celebration. They'll be at other museums and locations around Indianapolis as well. So if you have fun tonight, please check those out. And please make sure that you come back and visit the Destination Station here at the museum. Woo! Thank you to our community sponsors who make this all possible by donating their time and resources and talent. A shout out to Indy Chamber, Harrison Center, Smallbox, KA+A, CICF, and Sun King Beer, who keeps us flowing with really good brews. I wanted to introduce our special guest for tonight. Ian Meginnis is a spacesuit engineer at NASA's Johnson Space Center. He graduated from Purdue University in 2010 with a BS in aerospace engineering, and he received a graduate degree in aerospace engineering from Georgia Tech in 2012. He has been working on the advanced spacesuit development team at JSC since 2012. He has supported the development of the Z2 spacesuit design, NASA's latest planetary walking prototype spacesuit. He's also worked on designing a portable breathing air backpack that would enhance current spacesuit testing abilities. So without further ado, let's welcome Ian Meginnis to the stage to talk about the design of spacesuits.
How you guys doing? Good. Yeah, so as Janine said, my name's Ian Meginnis. I am a spacesuit engineer out at NASA Johnson Space Center. Today, I'll be giving a short overview of the Z2 spacesuit, and I'll also obviously be talking about some wearable technologies that we've been developing. And I'll also talk about this the spacesuit over here in a little bit. You guys might be wondering what that is. It's not Z2, it's a different suit. I'll talk about that in a second, though. So over the course of the short presentation, I'll start off. I probably won't give a personal background. You guys have already heard enough about me. I'll talk about exactly why we need a spacesuit and what it's used for. A lot of you guys may not be familiar with how we use a suit in space. Also talk about a couple of the different spacesuits that NASA's developed over the last 50 years. Then I'll move into the Z2 spacesuit, and then I'll talk about a couple of different wearable technologies, which include advanced materials and heads-up displays. Yeah, so as Janine said, I'm from Indianapolis, Indiana, and I've been working on the spacesuit team at JSC for the last couple of years. So why do we need a spacesuit? First and foremost, the reason that we need a spacesuit is that a spacesuit provides protection against the elements of space. Specifically, the suit provides pressure on the body, temperature control, and breathing in a breathable atmosphere, which for us as humans is just oxygen. And when we're designing a spacesuit, we have to ask ourselves two big questions. And the first question is, where are we going? So are we going to the moon? Are we going to Mars? Or are we just going outside in low Earth orbit? And that'll help define what types of environmental protection you need. So what type of materials you need. Do you need to protect yourself from radiation, from dust, or maybe even both? And then you need to ask yourself, what are we going to do once we get there? And this will help define what types of interfaces and mobility you need. So do you need to be able to walk around on the surface of the moon, or do you just need to be able to float around outside the International Space Station? And so asking ourselves those two questions, we designed a couple of suits over the last 50 years. More than that, but this is just a brief summary of a couple of the most recent ones. So the first one on your left is the Shuttle ACES spacesuit. It's the orange suit that they used on space shuttle missions. It was just a contingency suit. It wasn't nominally pressurized. And it didn't provide a whole lot of mobility features. It just was there to protect you in case the space shuttle depressurized. And the picture on the right, better yet, the one right here, is the EMU, or Extravehicular Mobility Unit. We like to use a lot of acronyms at NASA, and that's one of them. So this is used to perform EVAs. Another acronym basically means spacewalks. So this was used on the space shuttle and the International Space Station, and there was actually an EVA just this morning where they took, not this suit, but a similar suit, outside the space station to fix a couple of issues. So they still use this suit today. So it's not a walking suit. Obviously, you don't need to walk in space. It just has a lot of upper torso mobility. So you can move your hands, like that. You can move your arms. And that's what this is built for. So that moves me to the Z2 spacesuit. And the Z2 suit, it's NASA's newest prototype planetary walking suit. And the purpose of that suit is to basically allow an astronaut to walk around on the surface of a planetary body, or to enable them to move around in a microgravity environment. So it's kind of like a suit that we envision could do both things. And it's the combination of the accumulated knowledge from over 20 years of suit prototypes. So we've been working on advanced suits for a couple of decades now, and this is kind of everything we've learned from doing that development we've put into this suit. And it's also the highest fidelity spacesuit since the shuttle EMU. Up to this point, all of our suits have kind of been low fidelity. You can still pressurize it, you can still walk around, but you can't put it in, say, a vacuum chamber. Which is a very dangerous environment that we only do for suits that have been put under configuration control and things like that. And the overall plan for Z2 is to, once we build it and it gets delivered, we want to test it out in simulated environments. And then depending on if we like the design, we will build a flight-like version of it. Or if we don't like the design, we'll make some changes and then make a flight-like version of it. And the goal would be to eventually fly it to maybe the International Space Station or to one of the destinations that NASA ends up going with. So one of the most, neither of those other suits, but one of the most important things that we have to consider when we're designing a suit is sizing. So much like when you're, kind of out of my element here, but when you're creating, a new type of clothing, you want to make sure it fits somebody well and it's comfortable. But the same thing happens in a spacesuit. It's a little bit different. But basically, when we say we want the suit to fit you well, we want the suit to match up with humans' joints. So for instance, you have an elbow joint right here, and you want to make sure that the person's elbow joint matches up with the elbow joint of the suit. If you don't do that, you can have some performance issues. You may not be able to work with the suit very well, or you might get injured. So because it's such a big deal, we spent a lot of effort in doing this. And this is the first chance we had to kind of spend a lot of time on the sizing aspect of the suit design. And so to do this, we took 3D scans of our test subject, which you can see on the lower left over there. And then we had the 3D computer models of the Z2 suit, and we performed digital fit checks between the two things. And we were able to digitally ensure that the suit would fit our test subjects before we ever built it, which is something we've never been able to do before. So that was really cool. And then we took it a step farther and we said, okay, the computer models, make us think that we're happy. But we want to take it a step farther, so we built some Z2 rapid prototype structures that are obviously not the real Z2, but they are rapid prototype mock-ups. And then we took our test subjects and just had them get inside the mock-ups and make sure that the suit fit them and there weren't any issues or anything like that. So we've never been able to do that before. Before you build a suit, you kind of hope that it's going to work out, and then you build it, and then you test it, put the person in there, and then you realize maybe there's some funny things about it that you have to kind of modify it. So you put padding in places you didn't have maybe plan on putting padding in. So this is really going to help us build a suit that you can just deliver and it's going to work. So now I'm going to talk a little bit about wearable technologies. Specifically, I'll start off by talking about advanced materials. So breathable materials are very important to NASA in the spacesuit world. And by breathable, I don't mean that they can pass air, because obviously a spacesuit is airtight. I mean that they are water vapor permeable. So this means that if you're wearing a suit, water vapor can pass through it, but air cannot pass through it. So, some of our suits, they provide in-suit ventilation. Let me back up a second. So when you're in a suit, if you start to get hot, you can start to sweat, just like you would if you're not in a spacesuit. Now, if you don't provide a way for that sweat to evaporate and get away from your body, you're going to start to get really, really hot, just like being in Houston on a humid day. It feels really, really hot. So some of our suits have in-suit ventilation that helps remove that evaporated sweat from the human body. But some suits, like the ACES suit you can see over there on the lower right, do not have that in-suit ventilation. So they actually use breathable bladders that allow the sweat that evaporates to exit the suit and help cool the astronaut even more. So when they're sitting on the pad at Kennedy Space Center and it's like 100 degrees outside and they're really starting to get hot and start to sweat, the suit can provide a little extra cooling, which is something that we, they like, and we like too because they like it. Now, the type of material that's used with the ACES suit is called Gore-Tex. You guys have probably heard about it because it's starting to get used in commercial products a little bit more prevalently. You can find it in Gore-Tex jackets and Gore-Tex shoes, and I pulled that off the North Face website, so you can go to their website right now and buy a Gore-Tex space jacket if you wanted to. Tyvek is also another breathable material that's used extensively in commercial products. So it's not used in spacesuits, but it is used in things like athletic shorts and hazmat suits. So if you guys have ever seen somebody painting a house or whatever, they might be wearing a white coverall, and a lot of times that's made out of Tyvek material. And it's also being used in housing materials. So if you drive by a new housing development, you can actually see Tyvek paneling on the side of the house. I didn't recognize it until I saw the picture on Google, and I was like, oh, it's being used in housing development. I see it all the time. I just kind of overlooked it. So that's something that you can look for the next time you're driving through a housing development. So now I'll talk about heads-up displays. So when an astronaut is inside the spacesuit, they need to be able to control and monitor the suit's functions and the suit's status. These include things like how much oxygen they have left, how much power the suit has, what pressure the suit is at. And so currently the EMU, which is this suit right here, uses the Display and Control Module, or DCM, another acronym. And it's this big, bulky thing right here. So as you can see, it's really big, and it tends to get in the way when the astronaut wants to move his arms like that. He really can't, his range of motion is significantly limited. And it's also pretty heavy, which, if you're in space, you're weightless, it's not that big of a deal, but it makes launch costs higher, and if you're going to someplace like the moon or Mars, it's a pretty big mass to have right here hanging off your chest. So one of the things that we want to look at is other ways of displaying information to an astronaut. Do we still need this guy, or can we use a different type of technology to communicate the same type of information? So we've been working with a couple of different space centers, NASA space centers, and we've also working with commercial private industry trying to test and evaluate different types of technologies. So one type of technology that we looked at in the past, it's called a in-helmet EVA display. You can see a picture of it over there on the right. One of our test subjects is in the suit. And it's just a small, kind of almost monocle-like device that's mounted to the neck ring of the suit. And that's coupled with a computer trackball, which is mounted to the upper torso of the suit. And this was tested just in 1G operations. It wasn't tested in space. This is just kind of like a first cut. Hey, how does it feel? Do we like it or do we not like it? And we evaluated a couple of different things with this device. The first thing what we did was used it to navigate terrain using GPS. So basically, we overlaid a map on the display and then had the test subjects navigate to a couple of different waypoints. And they were able to successfully do this, and they did prefer this over breaking out a paper map and trying to figure out where they were and where they needed to go. But there still were some issues with it being completely user-friendly. So it was mounted to the side of the neck ring, so they had to kind of shift their head, close an eye, and look into it, and to figure out where they were. So it wasn't just always in their field of view, which is something that I think we would like to do if we're going to make this truly helpful technology. We also used it to view EVA procedures. So when an astronaut is, say, for instance, fixing a satellite or fixing a space station, which is what they were doing earlier this morning, they use this thing called a cuff checklist, which is basically a fancy way of saying it's a paper checklist that you mount to your wrist right there. And as they work through a particular task, they will just flip through the procedures just like you would here on the ground. But we wanted to try to find a way that, find something that would maybe provide a little more user-friendly and a little less distracting, because right now you're doing a task, you're looking at your cuff checklist, you're kind of going back and forth and can be a little detrimental to what you're trying to do. So that's what we overlaid on the helmet-mounted display. And again, the crew members, the test subjects did prefer using that over the paper method, but there were still some issues with the user interface and trying to make sure that as the astronauts performing the workflow, they're not having to stop what they're doing and then look in this little monocle device to figure out what their next task is. But we think it is a step in the right direction. I think that's a good segue into talking about something like Google Glass, or maybe talking about some sort of heads-up display. But these are the types of technologies that we're starting to look at NASA. So that's just a really short summary of, the Z2 spacesuit and a couple of different wearable technologies that we've been working on. But you can see that the spacesuit team is spending a lot of time researching and developing new technologies, but that's just a very small portion of the work that NASA is doing as a whole. And as NASA works to kind of extend their missions to thinking more long-term, so going to Mars or going to the moon, we're definitely going to be needing to develop new types of technologies, both wearable and non-wearable. So this is a great opportunity to really get involved with NASA, because wherever we end up going, we're definitely going to be needing new types of technologies. And that's all I have.
Thank you, Ian. That was awesome. And if you have questions, our next segment is a panel discussion, so you'll be able to ask Ian some questions at the end of that. I'd like to invite our panelists up on stage. We're going to be talking about wearable tech, fashion, and space. So how do all these disciplines intersect in topics like the Google Glass and other smart fabrics that are being developed. So Lindsay and Mark and Ian and Alicia and Justin and Santiago, if you want to come up on stage. We'll have a brief time for them to introduce themselves.
Well, hello. How's everybody doing? I'm Lindsay, and I will be moderating this panel of highly intelligent people that are going to blow your minds with their knowledge of wearables. We'll let them introduce themselves here in a second, but definitely the topic du jour right now in the tech space is Internet of Things, right? And I do want to read you the official definition of the Internet of Things, because it's very Jetson-like, but also mildly creepy, so figured I would read it. So the Internet of Things is a scenario in which objects, animals, or people are provided with unique identifiers and the ability to automatically transfer data over a network without requiring human-to-human or human-to-computer interaction. So sounds a little bit scary, but In reality, most of its applications are making people's lives more convenient than they've ever been and giving us access to more data than we've ever had access to. So certainly there's big predictions on what this space means, what it's going to be. Business Insider Intelligence actually has estimated that by the year 2018, there will be more than 9 billion devices connected to the Internet of Things, which will equal the tablet market by that year. And things like smart TVs, connected cars, and certainly wearables are all leading the charge in that growth. Many of the world's top technology executives has penned wearables as the biggest thing to happen in tech in the coming years, while consumers still stay a little bit skeptical, namely because of the cost of many of these devices, but also the potential risks to privacy. So we'll be addressing some of these topics with the panelists, and before we get started, we'll have them each give a quick introduction of themselves.
Hi, I'm Mark LaFay. I'm I'm a co-founder of Decodia. We're a software startup in the area, and basically what we do is we help kids with dyslexia be able to read without the assistance of parent, teacher, or tutor. And one of the applications we're going to be developing for is actually Google Glass.
I'm Alicia Decker. I am designer product development. I'm also event director for Pattern, and do a lot of fabric development and sourcing.
I'm Justin Zalewski. I'm a senior interaction designer at KA+A here in Indianapolis. We're a brand experience design firm, so I do a lot with user experience in general.
You know me.
There will be time, as Janine mentioned, for questions afterwards. If you just can't even take it and you have to ask your question in the middle of it, raise your hand, but otherwise we'll answer them at the end. So let's start with a softball question. Why do you guys think that wearable tech is so hot right now? It's been around for a while, and where do you think the largest growth opportunities are? This is the softball, people.
Sure, I'll start out. So I think there's a lot of factors that are making it really popular today and leading to the growth. Obviously, the technology getting to the point where it's commercially viable is a big thing. Processors are able to get real small, and not affordable to everybody at this point, but affordable to the point where a lot of people now have access to wearable technology. I think a factor that's coming into play as well is people are really starting to notice that smartphones aren't as convenient as they could be, and wearable technology has the capability and the potential to be a little more invisible, and provide a more seamless experience in a lot of ways than your average smartphone can.
Yeah, just to build on that, texting and driving I think is a great example. When you think about safety, looking down at your smartphone is not the best thing, but if you've got the Samsung Watch or if you've got Google Glass, assuming you're not in California, you probably won't get a ticket. So things like that, I think the ability to multitask better and more safely.
And in terms of the biggest growth opportunities outside of the ones that I mentioned, smart TVs, connected cars, wearables, is there anything that you guys have seen or read or heard about that perked your interest where you think that could be a big growth area in wearables?
Well, so Google Glass, I think, is a great indicator of where we're headed. You look at this, the idea of totally hands-free technology, whether it's on your face or if it's on your watch or wherever it might be. I think that's really what it's all about. So voice control, motion control, things like that. I think there's also been some advancements in things that are woven into fabrics as far as creating energy, even just advancements in solar. If you look at solar panels now, we've got transparent solar panels that are actually being used for windows, things like that. So, we think about wearable technology as things that we wear on our person, but I think it's really something beyond that. It's more like technology that's woven into the fabric of our culture, not necessarily just into, us as people.
So I think health informatics is probably a big one. So I think as a society, we're trying to become more health conscious and things like that. So if we can get more passive devices that maybe we can kind of keep on our person at all times that can kind of help us track the level of our healthiness, I guess you could say. So like Fitbits and things like that are becoming more popular, but maybe even a step farther with, tracking, I don't know, what you eat and what your body fat percentage is at all times, and I don't know, things like that. I think people would be interested in. I think we're becoming an information-heavy society, so the more information that we can get as people, I think people are just going to kind of gravitate towards that.
Thanks. You guys have all mentioned Google Glass, and it sounds like the astronauts were using heads-up displays before Google Glass was cool. The only place I see Google Glass is I go to a lot of tech conferences, and I see it there, but Main Street USA, I don't. So outside of the cost, which for many people it's cost prohibitive, what do you think is going to be the biggest hurdle to overcome to gain even a portion of adoption for the general consumer?
Well, so I think it's perception, really. So we were actually talking about this before the event tonight. But when you think about the iPad, I remember when the iPad came out, and I thought, who needs a tablet? This is really stupid. And I'm sure there's a lot of people out there that thought the same thing. Like, I've got a cell phone, I've got a laptop, I've got all these things. Why do I need a tablet? And what happened was, a year forward, maybe 9 months forward, the apps started hitting it. And so we started seeing, oh, this is how this makes my life better. And so I think that all technology falls on that curve where, at first we see new technology, we're all paranoid. We're like, oh, this is terrible. I can't imagine using this. This is going to be miserable to try to adopt it. And then we sort of get beyond that step, and the next step is more like, okay, maybe I could use this, and maybe there's some purpose here with this technology. And then we get a step further. It's like, okay, this actually makes my life way better. And I think that's what happened with the iPad. So, look at healthcare, education, whatever it might be. We're one-to-one with iPads in schools where, every surgeon, doctor, physician has an iPad or a tablet of some sort. And really what it took was other people, the general public, to create usefulness for that technology. So the same thing with Google Glass, I think, applies, and that is, this is a really nerdy piece of technology, and I'll put it on in a second so you guys can all see how nerdy it is. So, you look at the technology, like, why in the world would I ever use Google Glass? And I think in about 6 months to 9 months, when the general public gets their hands on it, all of a sudden everybody's going to have that eureka moment. They're going to say, oh, that's why we need Google Glass. And maybe it's not Google Glass. And I'm not even really particularly excited about Google Glass, but I think what is exciting about the idea or the concept of Google Glass, and maybe you guys agree, is where we're headed as a culture and with technology, and the way that technology becomes more of what we do, and the way we become more connected, and all that good stuff. And so, so I think glass right now is exciting because it represents the final frontier. Whoa, NASA.
Nice. Oh, I was just going to add, so I think I definitely fall into that bucket you were talking about as well, where I first saw the iPad and I was, why would I use it? But now that I have one, it's great, obviously. Right. And kind of an eye-opening moment for me, because when I thought of Google Glass, and even when I first tried one on, I was kind of think of it in the context of apps, and how am I gonna use this like I would use a computer or a smartphone. But the CEO of Evernote was noted recently as saying that apps are going to become obsolete. As we move from desktops to smartphones, and our average use session shrinks from a couple hours to a couple minutes. And as we continue to move to wearables, where that moves to a couple seconds, that apps no longer make sense in that context, and then it moves more to services that are just there for you. So when you think of things like Google Glass and wearables in that context, it becomes a lot more plausible, a lot more useful when you start to think of that.
As far as fabric goes, technology in fabric has been kind of under the radar, but we use it so often in outdoor products and things like that. It's similar to the Google Glass, where it just becomes part of your life and you just kind of forget that it was ever a technology. So I think that's where more wearable type stuff, other than fabric, what I know, is going. So just kind of something you expect to have day to day.
I can probably talk loud enough. And if you could, I don't know if you've seen, you hear a lot about these smart fabrics, right? You had mentioned where there's solar technology built into the fabric, and the textile is the power source. Have you guys seen any other interesting applications when it comes to these smart fabrics
Something I read about that is incredible. I don't know whether, I mean, this answers your question or not, but T-shirt OS, has anyone ever heard of this? No? It's a T-shirt that is actually 900 LED bulbs, and it communicates with the smartphone through an app. And you can display images, messages, whatever you're feeling. You can ask a girl out at a bar on your shirt. So, it's pretty cool.
You guys were talking about app development. I was recently at a startup pitch session, and someone came up and pitched an idea for an app that was solely for Google Glass, and there was no option available for the smartphone market. And I found that very interesting because you're not only betting on that your app will or will not do well, but also on whether the platform itself is going to gain adoption. Smart? Is he ahead of the curve? Is that, are you seeing more and more people doing that, or is that really a stretch and you should be developing for more than one application?
I think it depends what the application is and what the purpose is. Do you happen to recall what the app was doing?
I do not.
Okay. Because, yeah, I could imagine apps that would make more sense on Google Glass than they would on a smartphone, certainly. But if it's I guess in a general blanket case.
I do. It just came to me. You could, if you were out and about and you saw when I saw Alicia wearing a skirt that I liked, take a picture, and then they would do image recognition scan and try and find similar, either that skirt or similar skirts that are available for purchase, and give me those options.
I could certainly see that being a more Google Glass-centric app then. I mean, it seems a little creepy maybe to take out your phone and take a picture of someone you don't know.
Oh, you've done it.
To get that, I can't say that I have. But yeah, I could definitely see that being a glass-centric app rather than a smartphone. I think it all depends on the application.
Yeah, I think it's definitely crazy from the aspect that you're telling the general public to adopt a new technology to be able to use your application. So I think the beauty of developing for smartphones, tablets, and things like that is that there's existing infrastructure. So when we talk about barriers to entry to a market, you can look at developing an app, and maybe it's nice to use Google Glass, and it makes sense because it's from a user experience perspective. Well, this is way easier to do this and have it be more of a fluid interaction. But when you talk about building a business or launching a product, how many hundreds of millions or even billions of smartphones are in the marketplace, and why would you totally ignore that marketplace? For a piece of technology that only 18,000 or 20,000 people in the world have, actually 20,000 people in the U.S., and maybe 100,000 plus will have over the course of the next 365 days. So maybe they know something we don't.
That's what I was wondering. The folks at Pattern passed along an interesting quote from industrial designer Mark Newson. He said, "Product designers could benefit from fashion's efficiency in bringing designs to the masses with extraordinary efficiency, while fashion should adopt industrial design's material technologies and processes." As companies try to develop wearable tech that's both functional and fashionable, I think it would be very difficult to develop a product that is designed to fit everybody's body type in a general sense, and also be fashionable. Can you guys give some perspective on that, if you've been involved in that process, and the challenges associated with that?
So from a NASA engineer's perspective, I mean, we are very tech heavy and don't focus so much on making it look good. So for Z2, for instance, we had a cover layer voting contest. So we had the University of Philadelphia, their fashion department, I guess, design 3 different cover layer designs, and then we had the public vote on those designs. So we kind of recognize that we don't have all the expertise when it comes to making something look good. But that's certainly something that you need to take a look at when you're making a spacesuit that maybe an astronaut doesn't care so much about what it looks like, but when you're kind of using that to sell NASA, it's certainly something that we need to consider. And I don't think we've spent a whole lot of time on that in the past, and we're starting to, which is a good sign.
I don't have anything valuable to add, but it reminds me of anybody here a fan of Back to the Future? Back to the Future 2, Michael J. Fox with the jacket that readjusted itself and it dried itself. That's what I think of.
So I have something else to reply to that non-useful comment.
It's good. Let's keep it rolling.
Yeah, so that's probably one of the coolest things from me that, long term would be a cool type of technology that we could use for our spacesuit. So right now, you pressurize the suit and it maintains its rigid, non-movable structure for the most part. So that's why we have to have bearings that enable the people to actually move joints and things like that. But if you can make a suit that can kind of actively apply a certain pressure to every point of the body, such that maybe when you bend your elbow joint, you don't develop folds in the fabric. That's kind of like the holy grail from a spacesuit perspective that would allow you to get away from this big bulky design and let you try on. You can if it's something as simple as just putting on a pair of pants, hitting a button, and then bam, it shrinks down, provides you the pressure on the body that you need, so your blood doesn't boil. Then that's exactly what we want to see. We are spending time and money on trying to develop that technology, at least on a subscale component level testing right now. But that's probably 10 to 15 years out. So that's one of the things that mechanical counterpressure suits, which maybe some of you guys have seen, kind of relies upon. So that's like the holy grail for us, but down the road, I think it'll happen.
Very cool. Talking about down the road, I want to hear from each of you. If you could develop one wearable technology, what would it be? If all things are possible. Alicia?
Not necessarily a piece, but I'm very involved in the manufacturing process, so I would like to see automated sewing somehow. It's like the last process that hasn't been innovated, I feel like.
Can you talk a little bit more about that? How do you see that working, automated sewing?
Well, we do everything else. It hasn't been adopted commercially, but the technology is available for everything in the garment industry without boring you with all the details.
Oh, please.
Well, very exciting technology called direct-to-loom exists, where you can basically, just to give an example, you can put in a size, you can tell it what color, and a loom essentially knits that piece of pattern piece, so like this front leg of my pant. And so that exists, just to give an example, like everything up to sewing the garment exists, but nothing as far as actually sewing the garment.
So still using the electric sewing machines that a person has to
Yeah, just
man,
it's still a hand
woman,
process of all the innovation out there. That still remains a hand process. There hasn't even been that many innovations with the sewing machine in general, so, yeah.
Cool.
I guess I would love to see, and this may be something along the lines of Back to the Future too. I'm ashamed to say it's been too long since I've seen that movie, so I can't picture Marty McFly jacket.
Netflix.
Yeah, I'm gonna add it to my queue tonight. I would love to see fabric that adapts more to the environment, and I know there's certain applications that are in the works right now. But a pattern that you're talking about, the breathable patterns and stuff that allows water vapor through, something that adjusts to the environment, and sees when that's necessary. Maybe you can set your preferences, your temperature, spectrum, and when you want to be more shielded from elements and when you don't. That could be really nice.
Yeah, I like the idea of never having to put on a piece of technology. So like, when I go running or whatever, don't put a heart monitor on. I just put on my T-shirt. I think that'd be pretty sweet. Being able to get life vitals. I don't know if it'd ever be truly useful. I mean, other than exercising, but you're at your desk and you're working. You're just like, sweet, my heart rate's at 68 beats per minute. That's really helpful right now. But definitely in in the exercise side of things, I think that'd be pretty awesome. I don't know. That'd be weird to say I have a Bluetooth T-shirt, but that'd be cool.
Yeah, and there are some companies doing some interesting things that are getting closer to that. At Blast Media, we do some marketing for Adidas Wearables. They're my coach division. And they do have, what they call smart clothing, where there are sensors built into the T-shirt or built into the training bra. And it's still hardware, right? I mean, you can still feel the pieces in there, but it's part of the clothing that then speaks to your heart rate monitor that's also embedded. So it sounds like that some brands are coming closer to that, but it's certainly hard. There's still pieces of hardware that are in your clothing as opposed to it being one seamless piece. So, and Ian, most of what you do is what most of us would just love to do. So you're already developing some pretty cool wearable technology, but in your world or outside of your world, what would your sort of dream wearable be?
Yeah, so I think, what I'd mentioned is like the Holy Grail. I think that would be my ideal type of wearable technology. I mean, it's the application here on the Earth. I'm kind of maybe drawing a blank, but with respect to spacesuits, I know that having a sort of adaptable membrane, adaptable structure that real-time adjusts to what you need it to be, that would be great to have. So get on that.
Awesome. Well, I think that wraps up my asking you guys questions portion. So let's open it up. Does anybody out there have questions? I see one in the back.
So for Ian, a couple of questions. One is, if a malfunction occurs, suppose a guy is on fixing the space station and he tears the glove. Okay. Is it compartmentalized, just the hand, so the person doesn't die? And
it's a good question. No. So we kind of take it from a different perspective, and we try to reduce those hazards before they would present themselves. So the gloves are all reinforced with Kevlar and silicone, basically, to make sure that if it does start to get cut, it's not going to cut all the way through to the bladder and cause the suit to leak. But we have a lot of backups in place, so if there was a hole in the suit up to a certain size, there's a secondary oxygen pack that would kick on and provide you just enough oxygen that you would need to get back to safety, I guess you could say. So it's not compartmentalized, but we try to control it from a different angle.
And just one second question, if I may. There's too many, but I narrowed down to these two. How much of the Soviet Union development of the spacesuit has NASA used to develop this model or some earlier model?
So the EMU itself, the EMU was developed, in the 70s and 80s, and it was heavily derived from previous spacesuits. And of course, that was, when the Soviet Union was around, so there wasn't a whole lot of information sharing back then during the Cold War. So as far as the new spacesuit, we've kind of been pulling on our past knowledge and experience with our R&D suits. So that's where we have kind of drawn from. Personally, I'm not sure. I don't know. I'm sure there's been some information transfer, but as far as what I know, I don't.
All right, next question.
So I was kind of wondering what the difference would be between the suit on the spacewalk this morning versus like this suit. What are they kind of changed per the mission, in like little detail, or is there like any advancements a lot more since this?
Yeah, it's a good question. So there's a lot of advancements, fortunately,
Like
between this suit and the next suit. The biggest and probably most obvious is that you can walk around in the new suit. This suit, you can't do that. It doesn't have the bearings in the hips and the legs to do that. Another one from a materials perspective is that we're trying to think more long-term with the Z2 spacesuit. So it's something that you could put on the surface of the moon and it could get dust on and not, wouldn't have a problem with. The Apollo suits, which are kind of similar to this in that they were all soft, the materials on the suits actually started to break down and get worn through from the lunar dust, which is basically like sharp glass particles. So we're trying to think of materials that we could use in which that wouldn't be a problem. So we're kind of looking at composite structures and things like that for Z2.
Question over here.
I work on a computer-aided design Gerber pattern making system. For my full-time job and a part-time job, I work at the Art Institute teaching future fashion students. Can you tell me a little bit, like Alicia said, someone had to sew that. Can you tell me a little bit about the pattern making process and the cutting process and like who sewed that, if you know that?
Yeah, I can give you a little bit from what I know. So somebody actually did, physically sew it. I mean, unfortunately, it wasn't automated. We had, a whole variety of seamstresses that cut out that, first designed the patterns, cut out the patterns, and then put everything together and sewed it together with extremely tight tolerances. That's something that I kind of learned recently with the little bit of training that I got, was just how important seam tolerances are, because so they build the suit, but then they have to actually test each individual component. So testing seam strength and things like that. So does that answer your question?
Yes, it does. Is that done in-house? Is that done under your roof, or is that done overseas? Or?
No, yeah, it's all done inside the United States. One of the companies that we work with extensively is ILC, which is International Lake Tex Corporation. So back in the day, they actually made like bras and pantyhose, but got into spacesuits. So they're probably one of the leading experts on suits.
Yeah, I'm just like, when do we start seeing possibilities that we could make suits more fun-like, not serious stuff, like these white or gray, put a lot of colors like summer, Caribbean colors, some colorful suits and things like that.
So you're asking why don't we make them more colorful?
Yeah, they're too serious.
Yeah. Well, there's actually a very technical reason for why we make it just plain Jane white. It's very good at reflecting the solar rays from the sun. So if you made it a color like black, it would absorb all of that heat. Just like if you wear a black jacket on a sunny day, you get really hot. So that's the reason it's all white and not too exciting.
My question is about the wearable technologies and certain barriers to the marketplace, like rare earth elements, and how like 3D printing and those kind of new technologies will be affecting the marketplace in the near term and also maybe 5-10 years from now.
So the question's about rare earth?
Rare earth elements and how that creates a barrier to a mass market, and maybe like possible things of wiring it, and how like 3D printing, bringing the new resource of manufacturing through that, and how that would also play a role in opening up the marketplace. Kind of like pros and cons of certain technologies, and if that makes sense.
Sure. Well, so I'm not a specialist on rare earth, but I did read an article recently about how rare earth materials, there's actually been an abundance that have been found in North America. So I know a lot of the general concerns about being able to continue to develop high technologies, processors, things along those lines that require rare earth materials, how China sort of has a corner on the market. And so it's great that we found them here in North America, but I mean, you're right. I mean, that's definitely a concern as far as being able to create things like Google Glass and the Samsung Wearable watch, or really, I mean, any computer, any piece of technology that requires that sort of mineral. I don't know if that answers your question or anything, but I think the one thing, just sort of deviating, if I'm allowed to be tangential, I think it would be interesting to see how, as we start to get into nano processing and things like that, and looking at computations that happen at subatomic levels, I think that'll be interesting to see how that impacts wearable technology. So being able to see, your iPhone being able to do that level of computation on a device that's smaller than your fingernail. And I don't know if that type of technology utilizes rare earth. I know that it uses, spin of particles and things like that, but be interesting to see how that develops over the course of the next probably 2 years or 5 years, whatever it is.
Thanks, Mark.
I don't know if that helps.
We have time for a few more questions, so we'll go in order here.
Hi, thank you guys. A question I had was about, someone mentioned like wearables being invisible. Like, what are some principles around achieving that goal?
So I read another article. I think it's fascinating because there's actually an organization that created the first ever invisibility cloak, and I think that that's sweet. I mean, my total infantile elementary understanding of that is really it has to do with light refraction and things like that. So I don't know that you could ever have, well, maybe you could have, something that you wear that's invisible or, matches your skin tone or something like that. I mean, that would be easier, obviously, but I think really what's going to happen is that as technology continues to evolve, so if you look at the evolution of technology, it sort of looks like a hockey stick, like this, right? So over here we had the abacus, and then over here we had the Commodore 64, and then over here we had the iPhone, right? And then over here we had something else, and then as we create technology, technology makes it easier to create technology, and it has an exponential effect. So at some point, as we approach zero, we're going to head towards infinity. And so I think that what we'll end up seeing at some point in time is technology that gets infinitely smaller. And so maybe it's never actually invisible, like the invisible cloak, but it's so small that being able to weave that into the fabric of your clothing or being able to wear that, or I don't know if anybody's a Kurzweil fan, but the singularity, and it becomes part of our bodies. That's kind of awesome. I think that'll happen. And we're starting to see that as people are creating nanotechnologies. So these ideas of creating microscopic robots that they can actually put into your bloodstream that can deal with cancer and can deal with different pathogens and things like that. I think we're headed that direction. I don't know if that helps or if that answers.
Yeah, I think go along with what.
Sorry.
Invisibility.
That's what I think of when I hear invisible.
Invisibility cloak would be awesome for sure. I think going what you said earlier about when you put something on, you don't want it to feel like you're putting on technology or like you're wearing technology, like you have a computer on your head or a techie-looking bracelet necessarily. I think, and there's a lot of talk and progress on this already, of wearables moving into embeddables, I think is a possible direction that can lead to technology being more invisible. I mean, it's technically smaller, but it's not that it's become so small it's invisible, it's that it's become so small that you can actually embed it. Obviously, there's a lot of barriers there. Once you get into embeddables, the FDA gets involved. There's a lot of complications there that you don't have with wearables. But I think between that and smart fabric and technology, that it's just moving more and more in the invisible and unobtrusive direction.
Couple more questions.
Hi. This question is mostly for Alicia and Ian. Hi, Ian. When you talked about putting on your T-shirt and doing health monitoring with it, you didn't go where I was expecting you to go, and that would be for healthcare monitoring. So I can't think of anything more intimate or more accessible to measuring, the characteristics of my sweat, my core temperature, either for long-term spaceflight or for healthcare. What can we get to in the next 2, 5, 9 years for healthcare monitoring in our clothing?
Let's see. So I think that, for terrestrial applications, healthcare monitoring is something that we definitely want to be taking a look at. But I think that from a privacy perspective, people are going to start to be a little hesitant to adopt technologies that are maybe a little too intrusive. Maybe if you, I'm not sure. I'm having a hard time answering your question. So I have to think about it some more.
I can try to add some thoughts. So I think actually the privacy and intrusion issue becomes less of an issue when you're actually thinking about healthcare and when it's an issue of possibly life or death, and when you're monitoring, someone's vitals. I don't think they're that worried about, who's going to get a hold of my vital information. If this machine's going to actually make it easier for me to get healthy or to get the care that I need, I don't think that privacy is as much of a concern to us as might be wearing a more intrusive technology. I've seen a lot of companies working on things like this on baby monitors that monitor the child's heart rate and breathing, so the parents can sleep a little more soundly. And I think that's great progress and definitely one of the more noble efforts of wearable technology.
I can add something else to that. So on the International Space Station right now, health monitoring is a pretty big concern because of a lot of the issues that space flight kind of, does to the body. So right now, one of the big things, obviously, is bone loss. So when you go up to space and your muscles start to atrophy, so you can lose muscle mass, but you can also start to lose bone mass. So something they try to monitor before and after a flight is bone density and like how much muscle mass you have and things like that. So that's before and after you go back up and you come back down. So as far as what they do up there, I'm not sure, but that's something that people are very interested in taking a closer look at.
I had a question about as the Internet of Things becomes attached to embeddables, and wondered how much consideration you're giving to security. People joke about your refrigerator getting hacked or whatever, but it seems like as you have more of this kind of technology, it becomes more of a serious issue that people haven't paid much attention to, particularly when they've been making consumer products, for example.
I think I don't have a ton to add, but I think from a security perspective, I guess you're more liable when there's something more valuable for someone to steal. So what's the benefit for someone to steal the info off your Fitbit or from your refrigerator? I think that keeps people kind of sleeping a little more soundly. But I totally agree with you. I think as more things become connected, there's more places for security exposure, and it's something that definitely needs to be taken into account.
Yeah, I would agree. I mean, if we were to talk about boom industries in the future, I would say security is definitely one of those. Big data is a term that we all hear a lot more frequently these days, and we joke about the Fitbit, but Nike or Weight Watchers or whomever would grossly benefit from being able to have access to, the data from 10 million Fitbits, to be able to get that kind of just population information that's very intimate. That would be very valuable from a marketer's perspective. And, so I'm sure everybody heard about the latest SSL debacle, where all of a sudden there was just this really ridiculous hole found in SSL certificates, and it was very easy to hack. And so pretty much anyone and everyone that has an SSL certificate, so if you go to a website and it says HTTPS, if you're not familiar with that, everybody had to update that and patch the hole. So security is an issue, and that kind of information. I mean, information is money at this point. So I think that, to answer your question, I mean, security is a concern, absolutely, and being able to adapt to that is definitely going to be an issue.
I have a question for you, Alicia. Speaking of the CNC mills or the automated sewing, that's what I'm trying to get to. But what hurdles lie in the way of? Do you have any idea what sort of hurdles lie in the way of why this phenomenon hasn't occurred yet? Like everything else is automated, right? Like making of steel parts, things like this, but not textile industry.
I think, honestly, because the draw over the last 20 years has been to push production overseas, where labor is cheaper, that we haven't had to address that as much. So it's kind of a social aspect, but also a technology aspect, because we haven't had to look at that so closely. But I think it's going to come very soon, with duties rising and things coming back to the U.S. and people getting leaner that way. I think it'll be looked at soon. So
I think 3D printing will affect that.
3D printing doesn't really, I mean, because it, from what I know, I haven't seen anything as far as making soft products. It's hard products. So that doesn't really necessarily translate to what I know about garment production, but maybe some of these more wearable technologies is that 3D printing is still not a commercially viable option, but it is getting closer for sure. So it could be useful for some of these other technologies that aren't soft goods. It's a good question.
I'm interested in saving Southeast Asian children from making all of our textiles. So.
Me too. Woo.
I wrote tons of questions, so I'll limit it to one. You broached the subject just shortly about harvesting energy from wearable technology. And my question, if I can frame it well, is will there become a point where wearable energy harvesting fabrics and materials and whatever equals the energy consumption of the other wearable technologies so that we become, as it were, self-sufficient? Our own body movement and heat is generating the power that we need for the technology that we're wearing. And then there was silence. Okay.
I think if that were to happen, that would be, pretty monumental. I mean,
but is there any thought going towards that direction? I mean, it's a concept, but is there any movement towards that concept?
I think people are always looking for ways to get back any energy that they can and to generate it in any way they can to get as close as they can to that, kind of perpetual motion machine. As far as I know, there hasn't been any huge breakthroughs, but I think that's always something in any technology that they're striving for.
There are certain fabric technologies where, say, I don't know a whole lot about it, but say you take heat from sweating in your armpits and it makes it move down your body to warm yourself in other areas of your body. That's all I have.
Awesome. Well, thank you all for all the good questions tonight. I'm sure some of our panelists are going to stick around for another 15 minutes or so as they make their way out. So if you had a burning question that you didn't get to ask, then let us know. And you can also tweet at PatternIndy, and we'll connect you to them. So another big round of applause, and thank you for our panelists, for Lindsay, Mark, Alicia, Justin, and Ian. Thank you all so much.
One more thing I promised that I would mention. So the International Space Station is actually flying overhead Indianapolis tonight and tomorrow, I think. So you could walk outside, look up, and see 6 people orbiting the Earth. So what's the website called again?
Spotthestation.nasa.gov.
Yeah, so it's pretty cool. I mean, you can walk out there, and it just looks like a giant star moving slowly across the sky. I mean, it's pretty cool. So.
And I believe the picture behind you is a photo of Indianapolis taken from a space station. Not tonight. I wish that we had piped that in. That would be extremely awesome in technology and telecommunications. But it's awesome to see how noticeable the racetrack and Lucas Oil are in that photo. So thank you to the Indiana State Museum again for hosting us tonight. Please go visit the destination station here through June. And we also wanted to invite up a couple more guests really fast from the destination station tour to say a couple of words.
My name's Jenny. I've been one of the people in the fantastic group who's helped from NASA to put this together. And we wanted just to say thank you to PatternIndy and to the museum and to Janine and Paulina for helping us put this on. So we have a little presento for you guys. It is a picture of the space station. The picture that she was showing up there is down kind of in the middle. And it just says, presented to Pattern from your friends in the International Space Station program. So thank you guys very much for this.
Thank you so much. We'll definitely have to put this in the magazine next time, right? Can you tell we're really trying hard? International just won't do. We have to be intergalactic. Speaking of magazine, I wanted to introduce and announce our next meetup, which is taking place in May on the 22nd. We are going behind the scenes of Pattern Magazine. So if you've ever wanted to know how it gets made, how you can get involved, we're going to have the whole editing team there for lots of Q&A and discussion to tell you how that gets to print and from concepts. That will be at the Hinge on May 22nd. Look for details coming soon. Thank you guys. Have a great night.